Namaste. So students, today let us move on to the next experiment of DSP Lab, that is autocorrelation and cross correlation of a given sequence and how to verify their properties. Before going into the autocorrelation and cross correlation, let us see what is uncorrelation. Correlation. So it is a tool which determines the similarity between two signals. Based on that, you can decide what is the coefficient of correlation value. Now suppose if you consider two sequences or two signals which are exactly same, okay, in that case the coefficient value will be taken as 1. If the considered signals are entirely different from each other, in that case the correlation value will be equal to 0. Again, if you can take one more example where the signal values are exactly same, but the phase of a considered signals are out of phase with respect to 180 degree, then you can take the correlation value as -1. So based on the sequences, either you can assign a correlation coefficient value to 1, 0 or a -1. Okay. So with this, let us go to a first correlation type, that is a autocorrelation. If you are checking a similarity between the two same sequences, then it is called as a autocorrelation. If you are checking a similarity between two different sequences or signals, in that is termed as a cross correlation. Okay. First, let us see how to solve a autocorrelation equation. Then let us see how to write a program for autocorrelation. The correlation coefficient, it is always denoted by capital R. Okay. For a autocorrelation, it is considered as R XX, because I am considering the input X. With the same input, I am doing the correlation operation. Hence, it will be taken as RXX. The equation can be written as, which is equal to summation n is equal to -infinity to +infinity x of n into x of n minus k, where k is a shift parameter which may take a positive or a negative value. So you can choose a k value as k is equal to 0 plus or minus 1 plus or minus 2 or plus or minus 3. Okay. So these are the different values of k. So now by giving a different values of k and by considering any sequence for a x of n, let us solve this equation. Okay. Now I'll consider x of n equal to 1, 2, 3, 4. So this is an input sequence which I have considered. Okay. So now RXX of k you can include here. RXX of, give a first value for k. Okay. So as the k is having a -3 as a maximum value with respect to the negative axis, I'll consider RXX of -3. Summation n is equal to, see the considered sequence, it is having a value of 1, 2, 3, 4, which is ranging from 0 to 3. Hence, I'll take n value as n is equal to 0 to 3. X of n, write that as it is. X of n minus of, what is k value? Minus 3. You need to write now minus 3. Solve it. N is equal to 0 to 3. X of n, x of minus into minus plus, then it is x of n plus 3. Now expand the equation for the different values of n. Give the first value of n as 0, x of 0, x of 0 plus 3 plus x of 1, x of 1 plus 3. Next give the other value, x of 2 into x of 2 plus 3 plus x of 3 into x of 3 plus 3. So just have expanded this equation for different values of n, that is 0, 1, 2, 3. So now try to substitute the values. So in the considered sequence, what is it? This will be x of 0, x of 1, x of 2 and x of 3. So what we have here first? We have x of 0. What is the value of x of 0? It is equal to 1. Right? 1. Into x of 0 plus 3 is x of 3. So what is x of 3 value? It is 4. Right. Plus x of 1. What is x of 1? It is equal to 2. Into, see here, x of 1 plus 3 is x of 4. What is x of 4 value? We don't have a x of 4 value because it is ending at the value x of 3. And directly you can write here this value as 0. So 0 into 2 also gives you a value equal to 0. Plus, see here, x of 2 plus 3, x of 5. We don't have x of 5 value here. Can write it as 0. And same, x of 3 plus 3, x of 6. We don't have that also. Make it as 0. It is 0 plus 0. And what is our xx of minus 3 value? It is equal to 4. In this way, you need to solve all the values of k. That is minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So totally you need to get a 6 plus 1, 7 outputs for this particular equation. Okay. So when you solve the given equation for a different values of k, we are going to get an autocorrelation values as 4, 11, 20, 30, 20, 11, 4, where it is a value for k is equal to minus 3 to plus 3. Here I have indicated the 0th position value with the arrow. So in a 0th position, we are getting an amplitude of 30. So after solving the equation of autocorrelation, now let us see how to write a program for autocorrelation. Okay. So as we know, we have considered a input sequence as x. So initially you need to read this input sequence using a Matlab function called input. Now you all know what is the first line we are going to write for a Matlab program. It is CLC with clear all. After that, enter the input. How to give that? X, because I have considered x as an input. X is equal to input of, open the small bracket, within a single invited code, give the text. So what you can write here? Enter the input sequence. End it with semicolon. So whatever you write within the single inverted code, so that will be displayed in the command window of Matlab software. After this, now you need to calculate a autocorrelation of the considered signal. For autocorrelation calculation, in a Matlab, we have a function called XCOR. So this is a Matlab function which is used to calculate the autocorrelation or cross correlation of a sequence. So assign it to RXX because it is a autocorrelation. XCOR of, write the input, it is X. End it with semicolon. Now the autocorrelation value of X is stored inside the RXX coefficient. Now display this. Use a DSP within a single inverted code, right? The autocorrelation values are. So it is just a text, you can write anything within the single inverted code. So after this, you need to display the values also. So in order to display that, give DSP just RXX. First, the sentence will be displayed in the command window. Later, the values of RXX will be displayed. Then, plot it on the figure window. So in order to plot that, first you need to define the length of a output. So now let us assign the output length to small t. Since it is having a negative side as well the positive side, first let us write minus length of x minus 1. So what it gives, the length of x is a input, with that minus 1 the reflected value of that. 2, I'll give the step size 1. So it is increasing with respect to a step size of 1. 2. What is another value towards the positive side? It is just a length of x minus 1. So close the entire bracket. So how you need to define the length? Minus length of x minus 1 with this step size. Either you can write this or by default the Matlab will take the step size as 1. 2 length of x minus 1. So after this you need to plot it on the figure window. So since it is a discrete value, I'll use stem of. So as you all know, the first parameter should be the x-axis parameter, right, t. Then the next value should be the y-axis parameter, which is the amplitude of it, right, rxx. Okay, so this completes the plotting of the autocorrelation output. So with that, you can give here x label as time, y label as amplitude, and the title as autocorrelation. Okay, so this is a complete program for autocorrelation. So initially you need to enter the input. Later, using a Matlab function XCOR, you need to calculate the autocorrelation of it. Then display that on a command window. After that, define a length, then plot it on the figure window using stem. At the last, give X label, Y label and title. So in your program title, they have also asked to verify the properties of autocorrelation. The autocorrelation has a few properties which I have listed here. Autocorrelation function is symmetric. What do you mean by a symmetric? That means the left hand side and the right hand side of the obtained output will be always equal. That is, Rxx of m is equal to Rxx of minus m. So you can see the output value here. Apart from the 0th position value here, see here, what is the left hand side consisting of? 4, 11, 20. Similar to that, in the other side also we got the same value, 20, 11, 4. Okay. Since these two values are same, the autocorrelation function is always said to be a symmetric. Then the mean square value, okay, mean square value is nothing but an energy value which is always taken as a mod of x of n whole square. This value will be always equal to the 0th position of autocorrelation. And also in the autocorrelation, the 0th position value will be the highest value among the other values. Okay. You can see here, what is the 0th position value? It is equal to 30. Then if you take all these values and take the mod square of those values, it will be equal to 30 only, approximately 30 only. Okay. In the autocorrelation, the mean square value will be equal to the k is equal to 0th position value. Okay. So these are the properties of autocorrelation. So after executing the program, you need to verify these two properties also. Students, now I'll show you how to execute autocorrelation program in the Matlab. Click on the Matlab software. Wait until you get a window. Type a program, select new, in that script. So here in the editor window, you need to type a program. So I'll just paste the program of autocorrelation. So after typing a program, what you need to do? You need to save this program. Go to save, give a folder path. So preferably, as I told you, you need to create your folder in D drive with your name or user number. Just give the name to this. Correlation 11. So how you need to save this? With .m extension. Give save. So after saving this program, you need to run the program. Run. Give change folder. Okay. So when you are going to run this program, if it is error free, it will ask for the input sequence. Enter the input sequence. Enter the input sequence within a square bracket, either by giving space or by giving comma. Just give 1, space 2, 3, 4 as a input. Then give enter. So you'll get a auto-correlated sequence value 4, 11, 20, 30, 20, 11, 4. So in the equation calculation also you can verify this value. So after that you're going to get a figure window like this. So in this figure window you can also see the x and y values by clicking this data cursor. Okay. So select this data cursor in a figure window. After that, keep on the values, samples. So if you click on this, see here, what is the x value you have? -3. What is the amplitude you should get? 4. That is what here you are getting, first value 4. Similarly,
minus 2, 11, minus 1, 20. Like that, you can see other values also. At the 0th position, we are having a maximum value 30. Okay. So, in this way, you need to execute the autocorrelation program.
Now let us go to the next part of the program, that is a verification of cross correlation. As I told you, if you consider two different sequences or a signals, then it is called as a cross correlation. So now you need to check an relationship or a similarity between two different sequences. For that, I have considered two different sequences. One is a X and another one is a Y. So what is X? It is 1, 1, 1, 1. What is Y? I have taken it as 1, 2, 3, 4. The same equation you need to write now, that is R. There in the autocorrelation, we were writing it as RXX. For a cross correlation, I have to write it as RXY of K. Summation n running from minus infinity to plus infinity. Write the first input considered. It is x of n. Then into, what is the second input we have? That is y of n minus k we have to write. Where k is a shift parameter which ranges from 0 to plus or minus 1, 2, 3. It will be continuing like that. Okay. So now let us solve the equation for different values of k. As the k is starting from, according to the considered value, minus 3, I will put k value as minus 3. R xy of minus 3 is equal to summation. What is n? In both the inputs, I have considered the length of n is 4. That is 0 to 3. Write that. N is equal to 0 to 3. X of n into y of n minus k value is minus 3. So, within a bracket write minus 3. Then simplify this. N is equal to 0 to 3. X of n, y of n plus 3. Now, expand this equation for a different values of n ranging from 0 to 3. So, it becomes x of first value of n is 0. Write that x of 0 into y of 0 plus 3 plus x of 1 into y of 1 plus 3 plus x of 2 into y of 2 plus 3 plus x of 3 into y of 3 plus 3. Now start to substitute the values. What is x of 0? It is x of 0, x of 1, x of 2, x of 3, and this will be y of 0, y of 1, y of 2, and the last value will be y of 3. Now start to substitute the values. What is x of 0? It is 1. Write that. Into y of 0 plus 3 is y of 3. What is the value of it? It is 4. Plus, we have a value of x of 1. It is equal to 1. What about y of 1 plus 3? It is y of 4. Do we have a value for y of 4? No. You should directly make this value to 0. In the same way, here we don't have value for y of 5. This also 0. And we don't have a value for y of 6 also. It will become equal to 0. So, it is 0 plus 0 plus 0. So, 1 into 4. Here you are going to get a value as 4. That is r xy of k. The first value of it will be equal to 4. So, similar to this, you need to solve the entire equation for different values of k ranging from minus 2, minus 1, 0, plus 1, plus 2, plus 3. Now let us see how to write a program for cross correlation. The cross correlation programming also, it is almost similar to a autocorrelation. So first, before writing a program to cross correlation, I'll write a autocorrelation functions program also. Why? Because just to verify the properties of cross correlation. Okay. So you all know how to start a Matlab program. So start it with CLC. So later what you need to give? Clear all. Okay. So as here for a cross correlation, we have considered two inputs. Define the inputs. What are the inputs here? X and Y. X is equal to input. Give the code. Enter the first sequence. Okay, then we have another input variable called Y. Write that also. Input, enter the second sequence. Okay. So after the entry of inputs, let us perform autocorrelation individually on a variable X and on a variable Y. Rxx, okay, which is equal to, what is it? It is Rxx. That is, we are performing autocorrelation on X variable, that is X input variable. So you all know what is a Matlab function for correlation? XCOR. CO, you should write CORR. So in the last program, I have just left this. You need to write here double R for a correlation function. XCOR of, what is a input considered? It is X. So close the semicolon. Okay. So now we have got the autocorrelation of X. Display these values on the command window. DSP autocorrelation of X is. So this gives only sentence display. You need to display the values also. Give Rxx. Then go for a autocorrelation of Y. Ryy, which is equal to XCOR of Y. Okay, so this gives the autocorrelation of input Y. Display this. Disp autocorrelation of Y is, and give the value display. Disp of Ryy. End it with semicolon. So we have done with the autocorrelation programming of X then Y. Now let us move on to a cross correlation calculation of X and Y and X. In the next part of a program, write Rxy. What Rxy indicates? It is a cross correlation between X and Y. So now you need to write XCOR of, instead of only X or only Y, what you need to write now? It is X comma Y. And display these values on the command window. Disp. The cross correlation of XY is, display the values also. Disp of Rxy. Okay. Now perform the cross correlation between Y and X. You can write it as Ryx is equal to XCOR of Y comma x, because we are doing a cross correlation between y and x. And now display the values on command window. Disp cross correlation of yx is, display the values, disp r yx. Okay. So after this, you need to define the length of a program, then plot it on a figure window using stem function. At the last, give the x label, y label and a title. So assign again it to a small t. As a autocorrelation, it also includes a negative side and a positive side of output. So take it as minus of length of x, minus of length of x minus 1. What is the step size? Take 1, 2, length of x minus 1. Close all the brackets with the semicolon. Minus length of x minus 1, step size 2, a length of x minus 1. Next, give stem of t comma. What is the assigned output we have to display? So I need a cross correlation. Either you can plot rxy or you can plot ryx. It's left to you. So you can plot any of the value. So plot it, stem t comma rxy. Go for rxy itself. So after that, give a x label, time, y label, amplitude and a title, cross correlation. Okay, so this ends the cross correlation programming part. Okay, so this only a cross correlation. Why we have written this also? Just for the verification of properties. Okay, either you can do a cross correlation between x, y or a cross correlation between y, x. Both are same. Now let us see how to verify the properties of cross correlation. First, let us list what are the properties of cross correlation. So in the cross correlation properties, we have a first one, that is rxy of k is always a real valued function. So we got the output for cross correlation as 4, 7, 9, 10, 6, 3, 1. See the output of all the individual values of cross correlation, it is a real value, right? So hence easily you can say that always a cross correlation function rxy of k value will be real valued. Coming to the second property, rxy of minus k. rxy of minus k is nothing but a reflection of the output. So if you reverse the output, keeping 0 as it is, what is the output you are going to get? So this will be to the left side and this sequence to the right side. That's it. So 6, 3, 1, 10 will be as it is in the 0th position and 4, 7, 9. So this is rxy of minus k. Now let us equate it to ryx of k. What is the output we have? It is rxy of k. If you compute the output as ryx of k, then also this value will be reflected like this. 6, 3, 1, 0, 4, 7, 9. Hence, for a cross correlation, rxy of minus k is always equal to ryx of k. Next we have third property where it is a energy property as we have seen in the autocorrelation. The magnitude of Rxy of k square is equal to the product of the individual correlation values of 0th position. See here, it is Rxx. What it means? It is a cross. It is a autocorrelation of x. Ryy, it is a autocorrelation of y. The product of autocorrelations with respect to a 0th position is always equal to the magnitude of Rxy of k square. So this is an energy of the cross correlation function. Then we have when in the beginning of a correlation, I have told you the correlation coefficient may have 3 different values. One is 1, 0, minus 1. When it will take a value 0, when the two considered sequences are entirely different from each other. When the coefficient value is 0, we say that the considered sequences are uncorrelated, or these two are statistically independent from each other. Let us, when Rxy of k is equal to 0, that means we are getting an output as 0. Then what it means? X of n, y of n are said to be uncorrelated. At the last, we have a property Rxy of k may not have its maximum value at 0th position, may or may not. In an autocorrelation, it is mandatory to have a 0th position value as a maximum value. Whereas in a cross correlation, it may or may not be a maximum value at 0th position. So this is about the programming of cross correlation and its properties.
Now I'll show you how to execute the cross correlation program in the Matlab. Double click on the Matlab icon. Wait until you get a window. Then you can clear the other contents. Go to New, select Script, then type a program, then save this program in the specific drive which you have created. With .m extension, save. Then run the program, give change folder, then it will ask for the sequence, enter that. You can give any sequence. I'm just giving 1, 1, 1, 1, then 1, 2, 3, 4 as a second sequence. Give enter. Here you got all the autocorrelation and cross correlation values also, but only we have plotted the cross correlation values. So by clicking on the data cursor, you can also check the values and the graph, x and y values. Okay. So in this way, you need to execute autocorrelation and cross correlation programs in the Matlab. Thank you.